You are listening to EE Times On Air, and this is EE Times Current. I'm Eric Singer. Today's podcast is sponsored by Synopsys. Our technology, your innovation. Our guest today is Shekhar Kapoor. He's an executive director of product line management for the Synopsys EDA group. He's responsible for multi-die design, which is what we're going to be focusing on today, digital platforms, and analytics solutions. He has over 20 years of professional experience managing the design, realization, and sign-off products at Synopsys. Prior to that, he held leading design and application engineering roles at LSI Logic, which we now know as Broadcom, and at IBM. Shekhar holds an MS in electrical and computer engineering from Virginia Tech and an MBA from the University of California, Berkeley. So at the time of recording this, as we creep towards the end of 2025, we're seeing an unprecedented surge in AI investment. Hyperscalers are forecasted to spend nearly $3 trillion on AI infrastructure and data centers by 2029. And in that context, new partnerships are forming, such as the recent OpenAI and AMD strategic collaboration. Shekhar, what are your thoughts on this announcement and its impact more broadly?
We are indeed at a hugely exciting time. The scale of AI infrastructure investment right now is truly remarkable, and it's reshaping how the entire industry collaborates and innovates. In the context of the AMD and OpenAI announcement, it's a key milestone in itself. Just to give a little background, OpenAI will deploy up to 6 gigawatts of AMD Instinct GPUs, starting with the MI450 series in 2026, and it's arguably one of the most advanced and complex multi-die advanced packaging design. This announcement actually is not just highlighting a procurement deal. It highlights a deep, long-term alignment between AI's growing compute needs and the semiconductor technologies that enable them. OpenAI's move reflects a growing recognition of the importance of custom silicon and dedicated AI accelerators to enable and sustain this AI growth. In a way, it marks a turning point. AI and hardware are now advancing together, one that will more firmly align silicon roadmaps with the performance, bandwidth, and energy needs of these AI workloads. And that level of alignment means faster development in the industry, better efficiencies, and a new positive feedback loop. AI-driven requirements are now directly influencing semiconductor design, and those designs in turn are accelerating the pace of AI progress. And as this cycle deepens, semiconductors sit squarely at the center of the AI revolution, defining how compute is scaled, optimized, and deployed. So overall, this announcement is a very healthy sign. It would bring new investments into the semiconductor industry and drive innovation across the domain, across silicon, new developments like advanced packaging, and overall EDA tools. This announcement underscores exactly why Synopsys exists at the center of this transformation. As AI compute scales to multi-gigawatt systems, as we talked about in the announcement, the complexity of multi-die integration is exploding, and that plays directly to our strengths. We've been working closely with many leading chip makers across the industry on multi-die integration for years, tackling real design and verification challenges from planning and integration to analysis and sign-off.
I want to pick up on something that you said there towards the end, describing this as a feedback loop. And I think that's a really important point because as semiconductor industry and the AI companies are growing together, there's this flywheel effect where we're accelerating development on both sides. Why do you think collaborations like these are becoming so important right now? And what's driving this wave of hardware and AI convergence across the industry?
This whole partnership, this collaboration really highlights the recognition of how central silicon has become to the AI progress. So put simply, there are two big forces I see which is driving this convergence. First is pure demand. AI growth has simply outpaced the traditional hardware scaling. We all talked about the Moore's Law in the past, and Moore's Law alone cannot deliver the leaps that today's workloads AI models require. We have data, bandwidth, compute are all rising faster than transistor scaling can really keep up. And this surge is really stretching the limits of what existing infrastructures and even supply chains can deliver. Essentially, so basically, hyperscalers are now who always in need of more compute power. They had to source from multiple partners, deploy multiple architectures to keep pace. So that's the first thing is really the pure demand to really cater to this AI workloads and the data infrastructure. The second is a strategic imperative. AI infrastructure has become one of the largest capital investments that we've seen. And every gain in performance per watt or yield efficiency now matters even more. Semiconductor companies are already innovating. We are moving from monolithic silicon to multi-die integrated architectures to help with this performance and efficiency needs. But to fully unlock the potential, innovation needs to kind of extend beyond the chip, beyond the silicon. And the opportunity lies in optimization across the hardware and software, the entire data center, if you may. And that's where these collaborations are so important. They connect these domains, which have historically operated separately, and enable this true end-to-end optimization. When companies like AMD and OpenAI partner at this level, they can co-optimize across the stack, the hardware and software stack. And what you get is really the more smarter, more efficient systems which are purpose-built for the AI workloads. So eventually, this kind of collaboration really shortens the innovation cycle too. And so no surprise, I mean, we're seeing many of these announcements now, and this is becoming the new operating model of this AI era.
Yeah, as our capabilities grow, so do the expectations. So let's talk a little bit about specifically multi-die design. How do collaborations like these accelerate semiconductor innovation in multi-die design? And how important is hardware innovation for driving progress in the capabilities of those AIs?
That's a good question. Hardware innovation has essentially become the new frontier for AI progress. So algorithmic breakthroughs alone cannot keep up with the scale of today's models. Real progress now happens when AI and silicon evolve together. The feedback loop, which we just talked about as well. So every new generation of AI models that we are seeing is stress testing the compute fabric. Everyone is on ChatGPT. And you can imagine the OpenAI's workloads, which are pushing compute, density, bandwidth, and memory every single day. To meet these kind of demands, multi-die integration has become the only viable path forward, enabling this higher bandwidth and power efficiency that monolithic chips simply cannot. And these are really the building blocks. The silicon is a building block of this entire data structures. So these collaborations play a direct role in the evolution of all these demands are really influencing the architecture choices that you make, the types of integration decisions that you make, integrating something like tens to hundreds of chiplets, which have different functions, CPUs, GPUs, and SRAM, and so on. There are high bandwidth memories, which are integrated together into these tight packages, and high-speed interconnects, which come along with that to achieve the performance targets. And then not forgetting the balancing of the power and the thermals for the real-world workloads. So that's where acceleration happens. When architecture, design, this integration, and analysis and optimization all happen together, evolve together with the workloads in mind that they're designed to serve. It doesn't stop there. These partnerships are actually energizing the entire ecosystem. We have foundries which are advancing these interposers, stacking technologies. Of course, us as part of the EDA companies, having worked very closely with the chip makers, we are doing our part involving the IP design analysis. That collective momentum is the feedback, that feeds into the AI progress. At the end of the day, software, what I would like to say, defines the AI's intelligence, but hardware defines its reach.
And that tees up nicely as you mention what requirements are being placed on the EDA companies. Let's talk about what impact this could have on the availability and the scalability of multi-die design solutions for AI.
It's pushing multi-die design from niche to norm. So until now, multi-die systems, we have talked about them and we've been at the forefront of it. So we've been fortunate enough to seen the very early initiation and progress and how it's wrapping up. But so far, they have been very technically impressive, but still limited by the tooling, the ecosystem maturity, and even the cost. But partnerships like these, like AMD and OpenAI, the announcement is really going to change it. bringing more visibility and urgency to this space, which will further accelerate the adoption across the industry. As AI compute scales to multi-gigawatt systems this announcement mentioned, the need for performance, power-efficient architectures is really unavoidable. And again, referring back to the monolithic scaling, which has reached its limits, multi-die, chipless-based architecture, advanced packaging are the only viable path. This and other recent announcements actually validate this shift. We have AMD, OpenAI announcement, and the scores of other announcements, partnerships that OpenAI has done. They give the ecosystem a clear reason to accelerate this availability and scalability of the solution. And ripple effects are already visible. We have foundries, really going all out in investments into 2.5D and 3D capacity. And even OSATs are not really far behind. EDA providers, as again, we are delivering on the portfolio of solutions for die, package, system dynamic analysis. We have high-speed die-to-die interconnects, and IP investments are gaining traction as well. So in a broader sense, this is democratizing access to advanced systems, turning what used to be a high-end engineering challenge into an available, manufacturable, and scalable foundation. Multi-die is actually essentially the new paradigm. And there is no option for the industry but to aggressively move towards the adoption and the availability of these technologies.
Absolutely. So do you think as multi-die becomes the standard, sort of table stakes for these kinds of chip designs, do you think partnerships like this will set new standards for multi-die design in AI data centers and in cloud computing?
Absolutely. Is a resounding yes, actually. What we're seeing from the developments in the data center. This is just the beginning, what we're seeing. The scale and intensity of AI demand are rewriting the data center design itself. From model training to real-time inference, the pressure is really growing.
Mm.
The first phase of this industry was heavily focused on the advanced large language model training, but now inference is generating a huge demand as well. All of this, is measured not just in flops anymore, petaflops and teraflops, but in tokens, the latency and energy per query. Every query that you put in ChatGPT has a cost. And so all that goes as a metric. The entire infrastructure is evolving to keep up with that. We have from chips to packages. Investments are going from packages to large-scale systems on wafers, and then wafers to full systems within a rack in future. And I would say not very distant future. So partnerships like AMD and OpenAI, they are defining this trajectory, driving the industry towards this modular, high bandwidth, thermally efficient architectures that can scale seamlessly. Multi-die, wafer scale, even these early panel-level packaging, all converging toward one goal, which is maximizing the compute density and minimizing power per token per query. So new standards for the AI data centers, if we think about that, this is how it's going to look like. You have die-to-die bandwidths that behave like on-die interconnect, silicon interconnects. Power delivery, which is co-optimized at the package level, not just at the finite level.
Mm.
Thermal and mechanical core design across the silicon and the data center cooling system. You have to take all of this into account. So data centers are transforming into essentially compute fabric systems, which are built from silicon up, where every layer from die to system is co-optimized. So in this new landscape, performance leadership isn't just about raw compute anymore. It's about how effectively that compute is delivered per watt, per rack, and then even per dollar, given the kind of investments that are going on. So that's where multi-die design becomes foundational, setting the blueprint for this next generation of data centers. To enable them to be built at scale and with all the efficiencies.
Yeah, you've done a beautiful job of setting the overall landscape for us, just discussing all these demands and the requirement for greater efficiency and optimizing every step of not just the design workflow, but the actual utilization workflow, power needs, everything else. Let's talk about how you envision Synopsys' multi-die solution evolving in this new landscape. And what role you expect to play in enabling the pervasive intelligence era.
This announcement and what we're seeing in the industry and where we are, it actually underscores exactly why Synopsys is at the center of this transformation. As AI compute scales, the complexity of the multi-die integration is exploding, as we can see, and that plays directly to our strengths. We've been working closely with AMD and all the leading chip makers on multi-die integration and tackling all the design and verification challenges, from planning and integration to analysis and sign-off. What partnerships like these bringing is they're bringing into spotlight the greater opportunity that exists to extend and deploy these solutions at scale, given all the complexity. Essentially, for Synopsys, this moment defines who we are. We are the enabler and the orchestrator of this era of silicon and system design as we see us. If you rewind back, every major semiconductor inflection, from synthesis to SoC integration to advent of FinFETs, have all been powered by one thing, which is automation. And now as the industry shifts to multi-die system, and the system-level architectures with all the complexities and the loads, automation once again becomes the breakthrough lever. And this is an area we've been investing heavily in, both in automation and as well as AI optimization. Synopsys 3D IC Compiler is one example, which is a single platform which unifies all the multi-die architecture exploration, planning, and implementation across the stack of dies, interposers, and packages. And then, system-level analysis and optimization is a big concern. So together with ANSYS Multiphysics, we enable this holistic co-optimization across power, performance, thermal, and signal integrity in the same platform. But what makes Synopsys unique is certainly this automated platform, but the breadth of what we bring. From the hardware to software, we have hardware-assisted verification, IP, and design tools. So this end-to-end solution is what is needed, and for the silicon to system development, it's a new landscape. But we're just not the way, going back to this whole idea of we are the enabler and the orchestrator. We are orchestrating this by providing all the solutions. But we're just not a tools provider, we're also a partner. That's where we are enabling this. And our vision is clear. As the industry moves towards multi-die packages, to wafer-scale systems, and rack-level silicon fabrics, we envision Synopsys to be the automation and intelligence solution that will make it practical. So we're continuing to partner with throughout the ecosystems, which is not just the chip makers, foundries, and more with the system companies, to help the industry move from this manual way of doing these things in the past to more automated, from fragmented to more unified, and from innovation to full-scale industrialization, if I may. That's the role we see for Synopsys, to turn this promise that is in front of us of multi-die and AI convergence into a more scalable design.
And that is why I was so excited to talk with you today. You have done a wonderful job of putting this collaboration between OpenAI and AMD in perspective for us. Your own insights and the institutional knowledge at Synopsys are, I think, incredibly interesting for those of us who aren't so inside of these deals. Your perspective is super, super interesting, and I expected nothing less. I was listening to our last interview from a couple of years ago, and it's been fun to see how many of your predictions from 2 years ago have come true since then, and I have no doubt that we'll be saying the same thing a couple of years from now, listening back to this. Shekhar, thank you so much for joining us again. We really appreciate your insight.
Thank you, Egg. This has been a pleasure, I would say. And actually, it's been fortunate to see this progress in the industry. We're still in the beginning stages. There's a lot to be done, a lot to be achieved. And I'm very happy to be part of Synopsys and this whole new paradigm.
It is an exciting time. Thank you so much for joining us.
Absolutely. Look forward to future podcasts as well.
That brings another episode of EE Times Current to its end. Thank you for listening, and thanks again to our guest, Shekhar Kapoor, and for Synopsys EDA Group for underwriting this episode. EE Times Current is available through the major podcast platforms, but if you get to us at our website at eetimes.com, You'll find a transcript along with direct links to the other stories we've mentioned and other resources. EE Times Current is produced by EE Times and Coop Studios. Our editors were Helena Melberg and Aaron Garrison. I'm Eric Singer. Thanks for listening.